Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder chapter 12. Build your understanding question number 9. The question is two particles of charges and masses plus q1 m1 and minus q2 m2 are released at different locations in a uniform electric field E in free space. If their separation remains unchanged, find the separation between them. Let us solve this question. The question given is two particles. Okay, one is this, one is this. Particle 1 is having mass m1 and charge q1. Mass m1 and charge q1 on this particle. Similarly, on particle 2, mass m2 and q2 charge in modulus is on particle 2. So these two particles are released in an electric field of intensity E. This is the electric field E. So what will be the separation R? This we need to find out. So if you can see on particle 1 which all forces are acting on it. One is the force due to the electric field. So since particle 1 is having positive charge, so the force direction will be in this direction and the magnitude will be Q1 into E. Other force will be the electrostatic force between the two particles due to charge having on both of them. On particle 1 is having the positive charge, on particle 2 is having the negative charge, so it will attract. So that is why force on particle 1 due to 2 will be in this direction. Similarly, we can show the forces acting on particle 2. Particle 2, F21 is the force on particle 2 due to the charge on 1 in this direction, because it will attract towards the positive charge. And Q2E will be in this direction because Q2 is negative charge. M2 means particle 2 is having the negative charge. So it will be attracted towards the electric field. So this is the force. Now, since separation between the two particles are not changing as per the question, so this can happen only when either these two particles are stationary or moving in the same direction with same velocity. Case 1. So this is the case 1. For this case to fulfill, the net force on particle 1 and net force on particle 2 should be 0. So if we write the NLM equation for particle 1, the net force to be 0, Q1E should be equal to F12. F12 we can write from the Coulomb's law, K into Q1 into Q2 divided by R square. So R square finally will be K into Q2 divided by the magnitude of the E field. This is equation 1. Similarly, from NLM, we will write the equation for particle 2. So net force to be 0, F21 should be equal to Q2E. We will put the value and we will be getting R square will be KQ1 into divided by E. If you see equation 1 and 2, Q1 is having different value than Q2. So R, the value of R obtained from 1 will be different for the value of R obtained from equation 2. But you can see the R value should be only 1, because initial condition is that the particles are released in the electric field at certain distance that we have assumed as R. So R should be only 1. So this case, consideration of this case will be wrong for the separation R to be same. So now what will be the second case? The second case, when both the particles, particle 1 and particle 2, moves in the same direction with the same acceleration, the separation will remain same. So we will write again from Newton's law of motion on particle 1, Q1e in this direction minus F12 should be equal to M1 into A. So Q1e minus K Q1 Q2 R square will be M1A. This is equation 3. Similarly, we will write the equation of for particle 2 by NLM. So F21 minus Q2e will be M2A. Putting the value of F21, we will be getting equation 4. So we are to find the value of R. A is unknown for us. To eliminate A, we will divide equation 3 by 4 and we will be getting this. Upon solving and putting the value of K is equal to 1 by 4 pi epsilon naught, we will get the final result of R as half of, in bracket, Q1 Q2 in bracket M1 plus M2 in numerator divided by pi epsilon naught E in bracket Q1 M2 plus Q2 M1 in bracket in denominator, and the whole thing under square root. So this will be our answer. So hopefully you understood the concept. If in case any doubt, please do write in the comment box. I will clarify. Thank you.